My name is Dustin, and this is my presentation on hypothesis testing using the spectrum inventory data. So like I said, I used the spectrum inventory usage data, and here's a screenshot of that data. You can see there's information about the customer, the order date, and the order size. And the very right-hand column where it says pounds int is actually a column that I added myself, and it's just integer values of the pounds column. The reason I added this column was because when I was playing around with data in R, I kept getting weird data type errors, so I decided to get rid of that error by just making everything an integer. And the question I'm trying to solve, or the question I'm trying to answer with this data was, is there a statistically significant difference in the pounds of meat delivered between the weekend and the weekdays? And to answer this question, I decided to use a two-sample t-test to compare the means of the pounds of meat delivered. My null hypothesis was that there is no difference in the mean pounds of meat delivered during the weekend and the weekdays. To work the data in R, I first imported it and then loaded all that data into a data frame. And then I decided to simplify that data frame by just pulling out the two columns of data that I was interested in, the day of the week and the pounds of meat delivered. So for the day column, that was just a column of integers 1 through 7, where 1 represented Sunday and 7 represented Saturday. So 2 through 6 represent Monday through Friday. And then the pounds int is just integer values of the pounds of meat delivered. Preparing the data a little bit further, I split up that data frame into two separate data frames, one called weekend and one called weekday. The weekend data frame was just all the rows that had a day value of 1 or 7 because, like I said, 1 corresponds with Sunday and 7 corresponds with Saturday. And then the weekday data frame was just all the rows of data with day values corresponding to 1 or not corresponding to 1 and not equal to 7. So 2 through 6 basically. And then I ran the t-test where I used, for my two input arguments, I used the second column of the weekday data frame, which was if you remember, which was the pounds of meat delivered, and the second column of the weekend data frame. And from the two sample t-test, I get a t-value of negative 9.1566 and a p-value of 2.2 times 10 to the negative 16. So that p-value is very, very, very small, which is a good sign because that means that it's a very, very small chance that the results I'm getting is due to error or due to random chance, and that means I can reject my null hypothesis and accept an alternate hypothesis that there is a difference in the pounds of meat delivered. And the t-value being negative means that there's less meat being delivered during the weekday and more being delivered during the weekend. And that's my presentation. Thank you.